So the toy is finally finished. You have your clock where you can move your hands around, and then you have your shapes, which are magnetic, which can come out and go back in. And then if we turn the power on, we'll reset this, and we'll reset this back to the start. So let me move you over. So we can see that we have electronic dice in here. So if you hit roll, the dice rolls. Comes up with a 4. So we can move the red horse 4. 1, 2, 3, 4. Now it's time for the blue horse. And he got a 5. 1, 2, 3, 4, 5. And so on, till the one hits the finish line and they win the race. So that's the racetrack portion. Keeps going till somebody hits the finish line and they've won. Same with the blue. The second part of the thing is the binary counter. And we can see that 0, 0, 0 equals 0. If we put a 1 up, we can see that 0, 0, 1 equals 1. If we put a 2 up, 0, 1, 0 equals 2. If we put a 4 up, 1, 0, 0 equals 4. If we want 3, we need 2 plus 1. We got 3. We want 4. We want 5, we got to add 1. If we want 6, we got to add 2, and if we want 7, we have to add all 3. So that's the binary counter part of the toy. Up. Then there's a piano portion down here. If we press this button, till you hear that noise. And then the piano has a second function if you push this again. Push it twice. You follow the colors. And if you miss, so you can see that, that challenges you. And then if you want to be an aficionado, you can just press one key. So the kid can fake out his mom or somebody else. Then if you push this and hold it, you hear that noise and it goes off. So what is sound and vision? Well, sound and vision, you just push this button and the lights will follow what you're saying. They'll respond to sound. So that's the sound and vision part. And then the secret club is the thing, kids like to play with locks. So let's open the lock. Let's open this lock. And then, I'll probably get a copyright strike for this, but when you open the door, we won't let that play too long because try to avoid a copyright strike, but that's what that does. It's battery powered. The battery is supposed to last about 14 hours. And we'll take a look at the back of it. So I'm not completely finished dressing out the wires, but the piano comes into this exciter down here. There's your dice. There's your racetrack portion, your piano portion down here, the speaker, your battery. It's just one 18650 battery with a charger right here. The music module, the MP3 module's right here. There's an amplifier right here which is controlled by this volume knob. And this is the sound and vision board. So let's talk about the racetrack. The racetrack's a pretty simple circuit. You have two CD4017 decade counters. This is an LED chaser circuit that was stolen off the web. And instead of the 555 they used to trigger it, we just want to use our push button. We can call this the red button and the blue button. And that's how we get the segments to go from one to the next. So basically what we have here is a Schmidt trigger used as a debounce for the clock circuit. The clock circuit comes in on 14. So you push the switch and it comes in through this ST74HC14 Schmidt trigger. So what happens is this circuit debounces it and allows a clock pulse to go to 14, which then the counter goes and turns on the output at 3, which turns on the first LED. You hit it again, it cycles to the second output, which turns on the second LED, all the way up to number 10. And then at number 10, what happens is you get a carry out 12, which goes to 14 on the second CD4017 driver, which switches the ground. These transistors here on 2 and 3 switch the ground, so you could see that 3 is the first output, so the ground is going to be 1 through 10, and then when this comes through, it switches the ground, so you get 11, 12, 13, 14, all the way up to 20. So that's basically how the racetrack works. There are two of these circuits, two of these CD4017s with the LEDs. So there's 40 LEDs in all to run the racetrack. And there's two of these debounced circuits, and they both use the same same Schmidt trigger. This just uses pins 1 and 2. And this uses 3 and 4. And that's basically the racetrack portion. And this is the dice part of the racetrack, and it's just a kit that was bought off eBay. Here's the schematic. The 555 timer causes the roll. You hit the switch, it rolls for a period of time, and then comes up with your 1 through 6 your 1 through 6 dice indication on the dice part. The only thing that I did different to this circuit was connected up the power and added additional lines so I can get a separate switch. Outside of the circuit, and then mounted the circuit board so you could see it through the window. So this is the binary counter portion of the circuit, and I've included the main power bus in this one just because this 5 volts powers everything. But basically The whole toy is powered by one 18650 battery. There's a 4056 SMA adapter charger that feeds the battery, and you can charge the battery back up. The main power switch is included in the binary coder section, and it's S4, so it's main power on and off, and it puts main power to a 5-volt bus that supplies the whole toy. So if we look at the binary counter portion of this, we're just using 74LS47, and it is a 7-segment driver. On the 7-segment driver, you have segment A, B, C, and D. All right, so we switch S1 on. We put a positive input on A. A is going to light up these two segments to create a 1. Okay? If we switch S1 off and we switch S2 on, which would be 0, 1, 0, which would equivalent to a 2. So that would put a positive input on B, and then this would light up the 2 segments. So you'd have this segment, this segment, this segment, this segment, and this segment for 2. If we wanted 3, we'd switch on S2 and S1, and that would light up the 3 segments. So basically, you know, you got your binary input on A, B, and C. D is constantly tied to ground because we don't want it to go past 7. It only goes 1 through 7, so we only need A, B, and C inputs. So this is just your standard 7-segment display. So it's going to take the binary input on A, B, and C and put out the decimal equivalent on the 7-segment display. The problem with this circuit was I didn't want to use 4 of these 7-segment display drivers, so I had to find a way to cheat the system. And the way that I did that was, in other words, you know, you want your 0, 0, 0 to equal 0, 0, 0, 1 equals 1, 0, 1, 0 equals 2. So I wanted to display 0s and 1s out here to represent the binary number. So how I did that was I just took and naturally in the display 0, the 1 is always going to be lit as part of that 0. So what I did was I just tied 5 and 7 of the 7-segment display to a 270 ohm resistor, so they're constantly on. So the way we switch off 0 and 1, I figured if we turned off these segments out here, we'll have a 1. If we have them on, we'll have a 0. So the simple way that I did that was up here on the switch, say S1, this is to the indicator, this goes to the transistor of the 1. So in other words, I'm looking for 0, 0, 1 equals 1. So this is automatically going to figure out what 1 is here, but we need to display the 1 here. So the way we do that is we turn this switch on, it puts a high on 7, creates a 1 out here. Then that high pulse comes in across this 10K resistor and turns this 2N222 transistor, it's an NPN transistor, on, which then grounds this point. At a ground at this point, it's going to turn these 4 LEDs off, leaving us with a 1. So in the non-conducting mode, when this is having a ground out here with this transistor off, 5 volts is going to come down and turn on these segments. So you have you're shown a 0 when this is off, and then when we turn this transistor on, it turns these segments off and creates a 1. It was just a tricky way to display the binary number out here and not use another chip. It just uses a transistor, an extra couple resistors, and the same 7-segment display. So the rest of the parts of the toy are pretty easy. The piano, I took apart and extended out the audio lines, ran them to a Dayton exciter attached to the frame of the toy. Power was extended out and an external switch was extended out. The Mickey Mouse audio section works by 5 volts. It goes in. When the door is open, this switch closes. That applies power to the DF mini player chip. The DF mini player chip has a ground on pin 7 and I think it's pin 10. So it gets its ground there. But what turns it on is if you take the ground and you tie it to the address key 1, then the DF mini player will automatically play the song that is on the TF card. That comes out the digital audio control right and left. I have them both tied together for a mono output. That goes over to a 386 module on the back of the cabinet, which you can control the output because this would drive you crazy after a while. So the audio goes in that module, you got your 5 volts, and you got your audio out to the speaker, and it's controlled by the volume knob. One thing I did do is I put a 555 auto timer chip in, which flashes some LEDs and lights up the plastic, but it doesn't work very well. So this is kind of an optional but unnecessary mod. The sound and vision portion's pretty simple. You just build the module. It takes a power input, and when it's got the power input, there's a mic on this thing that controls the LEDs by the mic. And all you do is push the button. It supplies 5 volts to the sound and vision, and the lights flash. And that's it. That's the whole toy.